So, hello everyone, my name is Khawer Shafqat and I am a PhD student in Environmental and Chemical Engineering Research Unit, University of Oulu. So, I will be talking about the status of the active water treatment technologies at our research unit. And then there will be another participant for this presentation, Uzair, and he will be talking about the passive methods. So we will have the half time for this presentation. So first we can look at what is the active and passive treatment methods. Actually, in active treatment methods, we will require the equipment and it will be a regular operation and we will need chemicals. But we can also produce the water which as per requirement. And some of the examples of the active method is adsorption, membrane filtration, and catalysis. And in the passive treatment, it is basically utilized, it utilizes the biological and geochemical processes to improve the water quality. And some of the examples are constructed wetlands and bioreactors. But which is the better option? That depends on the site-specific requirements. So some introduction about how the mining influenced the water. So when the ore is explored, then precipitation and other environmental factors combine. And then atmospheric oxygen can react with the iron sulfide, which create sulfates, and then also with using the explosive for mining can increase the nitrogen compounds in the water. So in the chemistry of the explosives, when we use explosive for the mining purpose, so what happens is the NOx are released in the environment, so they further oxidize and they convert to nitrogen oxide compounds such as nitrates and nitrite. And also the reason because most of the explosives contain ammonium and nitrate in its composition. So we can have also ammonia in the water. And some of the pollutants, they come from the process. So when we are actually processing the ores after in the facilities. So for example, there are pH regulating agents and there are some also other chemicals which are used in the extraction of the desired metals such as cyanide and also nitric acid. So in our research unit at ECE, we have had a long history of studying the active treatment technologies for water treatment systems. For example, adsorption materials since 2005, and then photocatalytic treatment methods. And we also have membrane technologies. And in addition to this, we have hybrid technologies. For example, we can combine 2 or more technologies to achieve the desired results. So for example, adsorption and catalysis, and adsorption and membranes and photocatalysts, some of the examples. So particularly in this field, which is the theme of the today talk, we have 4 doctoral theses which are already finalized, and 7 theses are still ongoing, so which will be also in the future finalized soon. And research facility has photocatalytic reactors and also membrane separation unit. For example, you can see in the picture in the above there is a 1.5 liter, and then we have small reactor in the bottom which is half a liter, and then we also have a 15 liter capacity for photocatalytic reactor. So we can actually develop the materials and then we can test them, the activity of those materials. And we also have the different light sources. And in the separation unit, membrane separation unit, we also have a hybrid membrane equipment where we can combine the photocatalyst and membrane at the same time. And some of the examples from the recently completed project, for example, one of these projects called Vesimath, it was completed this year. So we have developed the materials which will be used as a catalyst for nitrate reduction. And at the same time, we have built an infrastructure for testing the catalyst and we can get the measurements in the real time. So for example, here you can see the reactor is connected with the measurement device. So we can actually see the reaction proceeding in the real time. So it will analyze the sample automatically. And one of another project which was recently completed is Agri-AS project. It was coordinated by the Geological Survey of Finland, GTK. And the idea was to study the arsenic in the soil and water, which was in the World War II, World War I destruction area in France. The samples were taken from there from the water. And the final recommendations after those results were made how the chemical weapon destruction sites and mining activities can affect the area or the water surrounding environment. So the results of this project, which were which you can see on the slides. So with the RO reverse osmosis, the efficiency of iron, calcium, and arsenic was more than 99%, almost 100%, and arsenic removal by the adsorption was achieved 75%. And the adsorption material in this study, they were actually used from the byproduct, waste products. So finally, I would like to acknowledge the foundation, Khawer Foundation, and MVTT for the personal grant, and also those people who are involved throughout those years for the studies. And here is the contact on the right side for our unit if you would like to cooperate or want to contact for any other reason.